Welcome to Naroj Masters Academy. In this session, today we'll discuss about atoms and molecules. So before going to start this chapter, atoms and molecules, do you know what is atom or what is molecule? So atom is nothing but a smallest invisible particle we'll call, or a matter which is made up of combination of atoms. It means if you consider a matter, if you cut into a small pieces continuously, in the end, finally, if you cut into continuously, and then you will get a smallest piece, which we cannot further get divided. Is it right? So that smallest piece is nothing but an atom. We'll call. So group of atom together, we'll call it as a matter. Is it right? You see here, if somehow we could go on dividing the matter, we will get a small and particles, smaller and smaller particles. Ultimately, we will get the smallest particle of matter, which cannot be divided any further. This smallest particle of matter, we'll call it as an atom. Okay, all matters is made up of small particles called atoms and molecules. Okay, if you see the golden biscuit or golden piece, if you cut further continuously, then you will get a smallest piece. Is it right? So that smallest piece is nothing but an atom. Now look at here. We'll study today about burning reactions. Okay, let us study the burning reactions. On burning charcoal, if you observe, it leaves ash at the end. Is it right? But where it is going, the amount of this burning charcoal, the complete charcoal, which is occupied a small, huge amount of space, after burning, it leaves small amount of ash. And what about the space which is occupied here, and what about the energy which is liberating? So we'll study that reaction, burning reaction completely. Okay. Do you think that where does the matter charcoal go? If you see this picture, the burning charcoal, which gives the small amount of ash here. Do you think about it? Where does it go? Yeah. If you see the scientist here, these questions and several other similar questions fascinated the scientist for many years. So these are all scientists. They faced a problem to get the answer for those type of questions and those many questions. So these questions and several other similar questions fascinated the scientists for many years. The burning and the combination reaction and puzzled them to get what we call to a greater extent. Okay, so these type of chemical reactions which are taken place for the further extension of the study of this burning. Okay, now that study will call it as a law of chemical combination or law of conservation of mass. Okay, combination reaction, decomposition reaction, and conservation of mass. So Laviers studied combination reaction in detail. Okay, so if you see, he studied the complete combination or combustion reaction, you can say the combustion of charcoal, combustion reaction in detail, how it takes place. What about the mass which is before burn, and what about the mass which is after reaction takes place? Okay, now Antony Lavoisier studied about burning reactions. Okay, 1743 to 1794 he was a French nobleman. Okay, he's a French nobleman. He was able to find the masses of reactants. Reactant in the sense before which takes place reaction, the left side of the chemical reaction we'll call it as reactants, and later we call it as remaining are products. For example, carbon and oxygen reacts together and gives carbon dioxide. Plus somehow, however, we'll get heat energy. So these two are called as reactants, and these two are combining together to form carbon dioxide, and this is what we call the product which is formed. Product which is formed. So right hand side of the chemical equation we call it as product, and left hand side of the chemical equation we call it as reactants. Is it clear? So he was able to find the masses of the reactants and the products accurately, irrespective of their physical states. Okay, he made many important contribution to the chemistry, and some call him the father of modern chemistry. Okay, so Lavoisier is the father of modern chemistry because he made many important contribution to the chemistry. The first important contribution is finding the masses of the reactants and the products, and both are equal. He proved that. So based on these observations, he proposed that law of conservation of mass. What he proposed that law of conservation of mass. Okay, law of conservation of mass. He proposed that. So what it says, law of conservation of mass says that the mass of the reactants should be equal to the mass of the products. Mass is neither created nor destroyed, but we can balance them. So to prove that, he conducted an activity. That aim of the activity is to find out the change in masses before and after chemical reaction. What is the activity name? Aim is to find out the change in the masses before and after chemical reactions. Okay, so see, we'll see here first what are the materials required here. Take materials required. So let me take the chemicals, the barium chloride BaCl2 and sodium sulfate, okay, Na2SO4 and distilled water, and then conical flask, and then small test tube, and then rubber cork, and then spring balance, and then retort stand, and then thread. So these are the materials which required to prove that the masses of the elements before reaction and after reactions are same. So these are the materials which are required to do the experiment now. Now look at here. First step, procedure. Prepare a solution of barium chloride. Okay. So barium chloride BaCl2. By dissolving barium chloride in a distilled water in a 250 ml conical flask. Take a conical flask and add BaCl to barium chloride into that. So this is what we call barium chloride salt. And take a conical flask of 250 ml size and add this powder into this conical flask, and then add some amount of water into it. So pour amount of water into this big conical flask and prepare the solution of barium chloride. So this is what we call barium chloride solution. Okay. Now step 3, take some solution of barium chloride in a small test tube from the above prepared solution. Now what you have to do? Take some amount of barium chloride in a small test tube now from that conical flask. Take the test tube and add some barium chloride in it. Okay, and then prepare the sodium sulfate solution now. Keep it away. So we have prepared just now BaCl2 solution in a conical flask. From that, take some amount of barium chloride into a test tube and keep it away. And now prepare the solution of sodium sulfate. Sodium sulfate is Na2SO4. So this is the sodium sulfate powder. Okay, and take one more conical flask and add the sodium sulfate into it and pour some amount of water, and then prepare the solution of sodium sulfate. Okay, so this is distilled water which is added here. And then now look at here, hang out the test tube containing the barium chloride solution in the conical flask containing the sodium sulfate. In your test tube 1, you are having BaCl2, whereas there is no second test tube for the sodium sulfate. Keep your conical flask as it is. This contains sodium sulfate Na2SO4. Now hang the test tube which contains BaCl2 in this solution without mixing. Without mixing as shown in the figure here. Look at here, take a stand, and then, and this is what we call balance, spring balance. Measure the weight of this sodium sulfate solution, okay, and which is having here cork and a conical flask, and then this is thread. And now hang the barium chloride solution in it without mixing. So here these two solutions should not mix together, okay. And now measure the weight. So what we are doing here experiment is to find the balancing of masses, mass before reaction and after reaction. Okay. Now measure the, note down the mass. Okay. Now look at here. Weight the flask with its concentrate. What is its content carefully using the spring balance. Now after balancing it, after weighing this one, simply mix together now. Okay, why? Because this is before reaction takes place, the mass of the reactants, barium chloride and as well as sodium sulfate. Now tilt the swill and the flask so that the two solutions mix together. Here mix in it, and you'll get the reaction between these two. Okay, after continuous reaction takes place between these two solutions, if you observe here, there is a precipitate which is formed in these solutions. In this solution, precipitate in the sense which is undissolved substance at the bottom. Okay, a solid substance which is formed in the reaction in between these two, that is barium sulfate. Okay, now after mixing these two, if you hang procedure again, weigh the flask again using the same spring balance as shown below or as shown in this figure. Okay, if you observe clearly, the mass of the spring balance is, there is no change. Record your observation here. Okay, weight of the flask and the content before mixing is also equal to the weight of the flask and the content after mixing. Both are equal. Is there any change in the mass? So before reaction, the mass of the two substances is also equal to after reaction. Here you have to notice that the point is the same amount of reactants and the products are not there. Why? Because in this reaction, barium chloride BaCl2 is different, plus sodium sulfate Na2SO4 is different. Okay, now together combined it and to form barium sulfate BaSO4 plus NaCl, sodium chloride, 2 times of Cl here it is. Now the salt is different, this precipitate is different. The salt solution is aqueous solution and this is undissolved substance at the bottom of the solution, which will represent with the downward arrow mark, and these two are reactants. But the overall mass, the complete mass of this solution, for example, if it is 10 grams, the sum of the products also is equal to 10 grams. Is it right? Why? Because there is no change in the overall weight in this reaction taken place. Before chemical reaction taken place is the mass of the substances is also equal to the after chemical reaction taken place. Now barium chloride when reacts with sodium sulfate, white precipitate of barium sulfate is formed along with the sodium chloride. You can see barium chloride BaCl2 reacts with sodium sulfate Na2SO4 and it gives rise barium sulfate, which is, we call it as white precipitate, barium sulfate, and also forms a salt solution, sodium chloride. And this downward arrow mark indicates precipitate. What we'll call it as precipitate in the reaction. Okay, when NaCl solution. Okay, so this is white precipitate. A chemical reaction takes place and the mass remains same before and after chemical reaction. Is it right? It means not individual masses, the mass of these two substances together is equal to the mass of these two substances after reaction. This is before reaction and this is after reaction. Therefore, the masses is neither created nor destroyed in the chemical reaction. In the chemical reaction. According to which law? Law of conservation of mass. Law of conservation of mass in a chemical reaction says that mass is neither created nor destroyed in the chemical reaction. Is it clear? So, in a chemical reaction taken place and the mass remains same before and after chemical reaction. Therefore, the masses is neither created nor destroyed in the chemical reaction. The chemical reaction taking place in this above experiment can be written as barium chloride solution plus sodium sulfate solution gives rise the barium sulfate solution white solid substance plus sodium chloride solution. Okay, in an experiment to verify the law of conservation of mass, the following data was obtained. The masses of barium chloride is equal to 20.8 grams, and the mass of sodium sulfate is equal to 14.2 grams. Together is equal to how much? We have to calculate. The substances which are formed is barium sulfates formed is 23.3 grams and mass of sodium chloride formed is 11.3 grams. Is it clear? If you observe here, in this case, barium chloride and sodium sulfate are reactants. Masses of these two substances is equal to how much? 20.8 plus 14.2 together is 15 plus 20, 35 grams. So these are reactants, barium chloride and sodium sulfate are reactants. Together the mass is 35 grams. Here the barium sulfate and the sodium chloride products which are formed here, barium sulfate and sodium chloride which are formed. Barium chloride is BaCl2 plus sodium sulfate is Na2SO4. Together reacted and formed barium sulfate BaSO4 plus sodium chloride NaCl 2 times, and their masses are, if you see here, mass of product is 23.5 grams plus 11.7 grams is also equal to 35 grams. It means the before reaction the mass of the reactant is 35 grams and after reaction the mass of the product is 35 grams. Since the total mass of the product is 35 grams in this chemical reaction equal to the total mass of the reactant 35 grams. Therefore, the given data verifies the law of conservation of mass. Is it clear? So, law of conservation of mass is defined as, according to the Lawyers, Antonio Lawyers, carried out the burning of chemical charcoal in a closed apparatus and found no change in mass. Okay, Antonio Lawyers, on the basis of his experiment, he proposed the law of conservation of mass. It states that matter is neither created or not destroyed during a chemical reaction. More simply the masses of products is equal to the masses of reactants in a chemical reaction. Can you define what is mass, law of conservation of mass? The law of conservation of mass says that the masses of product is equal to the masses of reactants in a chemical reaction. So, a numerical based on this law of conservation of mass. Find out this. 15.9 grams of copper sulfate, CuSO4, and 10.6 grams of sodium carbonate, Na2CO3, reacts together. Means these are the reactants. 15.9 grams plus 10.6 grams. These are the reactants together and reacted. And what is the total mass of these two? 10 plus 1.5, 25, 26.5. Is it right? And gives 14.2 grams of sodium sulfate. and 12.3 grams of copper carbonate. Is it right? Now 14.2 plus 12.3. How much it is? 26.5 and 26.5. Is it right? So which law of chemical combination is observed here, obeyed, and how? So directly we can say the answer is the law which is obeyed here is law of conservation of mass. According to law of conservation of mass, the masses of reactants should be equal to the masses of products. So here are equal. Is it right? So simple, the answer is copper sulfate solution plus sodium carbonate gives rise sodium sulfate plus copper carbonate. So 15.9 plus 10.6 gives rise 14.2 plus 12.3, 26.5 grams, 26.5 grams. So the total mass of product is equal to the total mass of reactants. Hence, the above reaction obeys the law of conservation of mass. Is it right? One more example. Carbon dioxide is added to 112 grams of calcium oxide. Okay, what is added here? Carbon dioxide is added to 112 grams of carbon dioxide. And the product formed is 200 grams of calcium carbonate. Okay, calculate the mass of carbon dioxide used, which and which law of chemical combination will govern your answer. Very simple. Carbon dioxide plus calcium oxide CaO gives rise CaCO3 calcium carbonate. So its mass is 200 grams. Its mass is 112 grams. How much amount we should add so that we will get 200 grams of calcium carbonate? So here how much it is there? 112 grams is there and the remaining balance is 88 grams. 88 plus 2 is 90 plus 10 is 100. 100 plus 100 is 200. So how much amount of carbon dioxide should be added here? 88 grams of carbon dioxide. Is it clear? And according to which law it is? Law of conservation of mass. Is it clear? Carbon dioxide plus calcium oxide gives rise calcium carbonate. Here mass of CO2 plus mass of calcium oxide gives rise mass of calcium carbonate. So mass of CO2 plus mass of calcium carbonate, mass of calcium oxide is 112 grams gives rise 200 grams of calcium carbonate. So here we should replace this so that we should get 200 is nothing but 88 grams. Mass of carbon dioxide is equal to 200 minus 112 grams, that equal to 88 grams. The law of conservation of mass governs the answer. Is it right? So in the next session, we'll discuss about law of constant proportion with numericals. Okay. So in the next session, we'll discuss about law of constant proportions. What is the constant proportion? And we'll discuss few problems based on this concept. See you in the next session. Take care.